Hello, everyone. Welcome to this edition of Infor TechTV Live. My name is Keith Knuth. I'm the Senior Director of Tech Product Strategy at Infor, and I'll be your host for this session. Hopefully, you've been part of one of our lives before, but the idea here is for this to be an interactive and fun way for you to learn about enterprise technology. We have a panel of experts that you can see around me that will help us understand today's topic of machine learning. But the really interesting content will be from you, our live audience. This is because you can use the chat session to post questions to the panel and drive the conversation the way you want it to go. So that's the fun part. If you're an Infor employee or an Infor partner joining the call and you know who you are, please keep the chat lines open for our customers. We want to make sure they get priority. And for everyone, please stay on the live to the very end. At the end, we will be posting a free download link to a Coleman machine learning cheat sheet that will give you definitions and resources and information about machine learning, all in a very kind of compact one-page format you can stick on your wall. So definitely something to print out and keep handy. Stay tuned until the end of the chat and end of the live for that. But before we go any further, and because this is a live session and I don't know exactly what's going to come out and what people are going to talk about, I need to post a disclaimer. Any number of topics may come up, including questions about like the future of our products and maybe dates when something's going to come out. So we just need to be clear that we aren't making any promises in this session about an exact date when we're delivering something. That's just to keep our lawyers happy. So with that out of the way, let's get to know our experts for this session. First up is Tanya Loskotova. Tanya, could you tell us a little bit about yourself?
Absolutely. Hello, everyone. It's my pleasure to be here. My name is Tatiana Loskotova, but I go by Tanya for short. I'm a Director of Science Solution Management. I'm here to talk to you about how you can leverage on a repeatable machine learning solution so that you can leverage on the power of your data and make more intelligent business decisions. I've been with Infor for a little bit over 5 years in different roles, from business consultant, product ownership, product management. And before that, I've also been working on implementing machine learning solutions, but mostly in forecasting, replenishment, and vendor collaboration space.
Great. Thank you, Tanya. Hassan, you're next.
Hi, everyone. I'm glad to be here. My name is Ehsan Saad Faridpour. I'm a senior data scientist at Infor. I've been with Infor for about a year. I lead data science, insights, and innovation showcases at IDEAS, standing for Infor Decisions, Analytics, and Decisions. My background is in machine learning and natural language processing, and I have worked in various industries like telecommunication, as software engineer or network administrator.
Great. Sarada.
Hello, everyone. I'm Sarada Vempati. And I've been with Infor for the past 25 years. Started as a developer, and now I'm the product director for Coleman AI platform for the optimization. And we have a new service called process mining, which we have just started. So I'm leading it from a product management perspective, the process intelligence suite. Yeah, I'm here to share what we are doing with Coleman AI, what AI in the real world is from business side, and how it could help you in the future.
Perfect. Thank you, Sarada. And last but not least, Kevin.
Hi, everyone. My name is Kevin Cole. Thanks for having me today. My background's in education and mathematics, and I've been with Infor for about 6 months. I've been tasked with creating informational and educational content for our machine learning platform.
Great. Glad to have you all. Thanks for donating your time today. I know being YouTube host isn't your primary job, so really appreciate your time educating all our customers. All right, let's jump into the topic. Remember, the chat line is open, so feel free, everyone watching, to start posting questions to our experts. I'll ask you to keep the question on the topic of Coleman machine learning, and also remind people that we can't do tech support on this call for your specific problem. So please refrain from those type of questions. Let's keep it to machine learning. Before we started, we had some questions come in. Thank you all our subscribers to the YouTube channel and whatnot. That you guys are awesome, subscribing and liking our videos. It's really helpful to us and telling us what to produce more of. So I appreciate your feedback. Tanya, the first question probably comes to you. The question was around the topic of AI and machine learning is very broad. What area of data science are we talking about when we talk about applying Coleman machine learning specifically?
That's a great question. Thank you for starting off with that. And before I go into the details on the applied aspect of the machine learning, let me just kind of take a step back and talk a little bit more about the definitions. I know the terms that you're hearing these days, AI, ML, deep learning, and a few others, have very trendy, but the reality of the things is artificial intelligence has been around since 1950s, and the reality of the things why it wasn't as used is because of the limitations on the computational power. And so when we talk about artificial intelligence, it's just a very broad concept to make machines intelligent. And when we talk about machine learning specifically, it's a narrow area, which is an application of artificial intelligence that enables a system to automatically learn and improve without being explicitly programmed. And when we talk about Coleman AI, it has different algorithms from supervised to unsupervised learning. When we are talking about Sarda and Asant can provide you a lot more details about each one of them. But what we want to focus on is in order for us to solve the real business problems, we need to get the data. When we work with our customers, we get the data from on cloud, we get the data from on-premise, we get the data from combination of different sources so that it can come together into the data lake. And then from there, we can leverage on the power of the machine learning. And in order to make it a little bit more specific, let me quickly just share my screen, which I hope will actually set the ground for us to go in a little bit more deeper discussions. So here, as you can see, the way how you can apply machine learning when we talk to our customers, we find that most of the problems will fall within one of the 6 buckets. So first of all, if you have been recently, adding some IoT devices, right, and trying to understand how you can use all of the streaming data to your advantage, or if you have some sort of quality control issues that you want to improve, we can apply some of what we call use cases around operational and process intelligence. Also, if you're in for customer, we know that in one way, sort of shape, you have some sort of equipment or assets. And if this go down in production, it creates a tremendous impact to your business, or you spend a lot of money, on maintenance and, trying to schedule things better. So we can help you to optimize some of these scheduling activities or predict assets from failing so that you're more proactive about things versus being reactive. If we are talking about any business process, right, if you're trying to think into the future, and we need to have some sort of forecasting coming in place. Let's say you want to understand how many people do you need to have on the floor. On one side, you don't want to have too many, but on the other side, you don't want to be short-staffed. So you can leverage on our forecasting intelligence modules for that. Or if we are talking about inventory, you want to make sure that you have inventory just in time so that we can predict the demand ahead of it, and we can also optimize inventory that way. We are very proud to also take into consideration the customer insights, right? Some of the problems around the customers, always retention, loyalty. So that's where machine learning can also come in handy to look at our customer base and predict certain risks. So again, we are more proactive versus reactive, and we can spend time to other more value add activities that will drive our sales force. Pricing on the other side, price drives demand. On one side, it's direct equation into your formula. On the other side, it will tell you how many purchases you're going to make. So given more suggestions of the prices, more visibility to the price, and machine learning can also help. And last but not least, human capital intelligence. Human is the most valuable resources within our organizations. Probably some of you dealt in one way, shape, or form through screening process, recruitment process. You know how long and lengthy this is. And we can help with the machine learning algorithms in there. We can also help with predicting employee churn, so to make sure that you don't have to react to certain scenarios and actually can anticipate and prevent it from happening. So we use a lot of predictive, prescriptive analytics to make you, to enable you to use the power of your data and to be more efficient. I know it was a very long answer to your question, please. I apologize for that, but hopefully it actually sets the ground for additional questions to come in that we can chime more.
That's okay.
That's
Tanya.
a really good point. Tanya.
I think these six boxes are really good to help us kind of put some scope around what we're talking about today. And Kevin, sorry, I interrupted you. Go ahead.
No, I just think that that's a really good point. Understanding these 6 buckets goes a long way towards one of the hardest parts of machine learning, and that's kind of taking these business problems and understanding how you even interact with your data to answer them. You know, artificial intelligence isn't just a magic solve everything. You've got to define your problem and decide kind of what algorithms are going to help you do, you know, predict or reduce costs or create a price target.
Pretty great.
Perfect.
Yeah,
Perfect.
I want to
Okay.
emphasize on focusing on customers as well, because customers are very interested in knowing what is applicable and can derive business values for them. And so the focus should be on them. That's the first plug that I really looking to do, working on those parts. Yeah.
Hassan, maybe you can help us with this next question. It was around kind of actual implementation of these type of solutions that Tanya talked about. The question was, when planning an ML project, what is the hardest part to estimate? What part is commonly underestimated in terms of time or complexity?
Yeah, thank you for that question. It's a good question. And thanks, Tanya, for setting up the level for the knowledge that we are talking about. So one of the things that most of the time is hard to overpass is how to communicate the output of the models in a way that users adopt that. So basically, they use the product that is built for them and they trust in that. So the time that needs to be going back and forth with the customer to make sure that the model that is built is actually what they asked, and also what is valuable and works for them, and they have trust in using that. Because if the model is very well designed and work well, but the customer doesn't have solid trust in the model or the end-to-end product, it's probably not being used as much as it can deliver results to reduce the cost, improve productivity, and lots of great benefits that it could have. So that part, because it has human involvement in between, that's very challenging for the time estimation and also getting back to how to overcome that. And normally we focus on a model to make sure that
Oh, Hassan, we're losing your audio and video there a little bit. Maybe check your local connection there and see if you can help out. Everybody else there too. I always hear that when doing implementations, like 60% or 80% of the time is data cleanup, data cleansing, finding the data you need. That everybody thinks the complicated part is, choosing the algorithm or something like that, but actually a huge chunk of the time is the data cleansing part. Can anybody talk about that or why that is?
Yeah, let me give you an example. Our experience when we did we picked up a use case for a customer without quoting any customer out there. So when the customer was looking into had a very good use case, they were clear what problem they wanted to solve, which is about predicting what parts would be needed so that you can intimate the service engineer whenever they're going on a maintenance of some equipment or something like that. What all spare parts should be taken together, wherein the historical data you should be having whenever you're maintaining that equipment, what all parts have been used, right? And this could be that you have in the history, like let's say the equipment has been in use for 3 months and then you maintain some part 1 and 2. But if it is, let's say, after 5 months, then maybe there is a part 3 which needs to be replaced because it is on the mileage. So that's very common sense, very clear, all good. So the customer said, can AI give us this information? Can Coleman solve the problem? Everything looks very clear. Problem statement is clear. The customer is clear. We know what applied machine learning problem it is. And yeah, we said, okay, let's take a look at the data. Now, when we look into the data, what we really find is that the time, right? The key factor here is you maintain an equipment 3 months later or 5 months later and so on, then the parts that which are used have certain variance, right? Now, when we look into the data, we find that the service engineer who is supposed to be maintaining in the history all the parts that which have been used has been doing everything only at, let's say, quarter end, just before he or she comes to the office, or after finishing all the travel, going across, meeting all the customers, solving all their problems. When they come back and they are then logging, it's more about logging. They have used the ERP more to log what service parts have they used, so that actually in the data you see the information of the part that which is used, but the time sense that which is needed is lost because they are not maintaining it at the time when it is used, but rather they are maintaining it at quarter end, right? In this way, what exactly is happening is that you can't use that data to solve the problem. Though the problem is clear and it's a wonderful one, the data is not there, and there is no way in which you can maintain the data, correct the data that which is in the history. The beauty, okay, while I say this for the data cleansing part, Keith, the beauty on the contrary is that this insight, when we do machine learning, something which every one of us should really understand, while it is cost saving or the benefits on the, let's say, the margins that which you get and so on, that is all very important. Machine learning and AI also give you a way to identify your processes are followed correctly or not. And if they are not followed, it gives you an insight to find those gaps, like what happened in the scenario with this customer, wherein a very neat process is defined, everyone is trained, but no one looked back into it, whether people were following it in the right way or not. So ERP is there, processes are defined, training is given, but implementation, measuring the implementation or monitoring the implementation is something which was missed out. And that is something which the customer has taken as a feedback, and they are now revising it. They have revised it. But that's, so when we really look at the data, in machine learning, in AI implementations, there are lots of stages. While sometimes the problem statements are not clear, sometimes people want to solve anything and everything with AI, which is not really true and which cannot happen. And then you look at the data, there is not sufficient data available. And then, or let's say the data doesn't contain the information that which we need. So all these really play a big role. So every piece has an importance in this big puzzle. But data, of course, is the key. And most of the times we learn a lot of things from the data, whether it contributes towards solving the problem or there are something more needed.
Yeah, Sarada, I would agree. And I think a lot of people don't realize until they've actually sat down to play with some data just how messy data sources can be. They don't always update at the same intervals. They're coming from different places. There could be missing values. And in order to match the math behind the scenes, a lot of times you have to make changes to those data. They might not be numbers. And if the math needs numbers, you've got to find ways of changing your categories to numbers. So just a lot of work goes into structuring your data before you can even feed it to the machine learning models.
Yes, and just to add on to this, we have noticed that we spend a lot of time doing what we call exploratory data analysis before we jump into the machine learning piece. And it's very important for us to understand like what the data tells us, whether there are any causalities or not. Sometimes we notice that there are certain gaps, and then the customer looks like, oh yeah, we have this information that's been stored that explains it in other system, and then we can add on to it. And lately we have started launching of what we call data insights program, so that we can actually, before we start doing any of the machine learning, we get together with the customer, try to understand the business problem, try to analyze this data, and the end kind of come a conclusion. Can we use this data to solve for this particular business problem or not? And then if not, we can always provide a lot of recommendations of how you can change some of your processes or how you can add on things so that we can set the ground to solve this particular business problem. Or we find actually this data can be used to solve some other problem, and here's the recommendation. So this is a very important kind of information to keep in mind that even if you cannot solve your original problem with the data that you have provided, we can use this data to solve some other problem, meanwhile giving you time to accumulate and to change some of the processes to move forward.
Yeah, sometimes you don't even know what data you need to start collecting until you answer that question of what problem you're trying to solve.
Exactly.
So that's a good point. In the title of this whole live was kind of real world business problems, right? So maybe some of you could share very specific. And Sarada, you did a general example about where data preparation was important, but more generally, what was the business problem a customer is trying to solve? What we used as far as a machine learning model to solve that? What was the outcome? Do you have some real world examples?
Can I take over screen sharing just for a second?
You go ahead.
Thank you. I'll try to be shorter this time, but I cannot promise.
That's all right.
All right, let me know once you're able to see my screen. Sorry, just some technical difficulties. There we go. All right. So the problem that we are looking at here is that a customer was asking us to predict failures of the equipment. And so this is just one user output. And then this user output, this particular user is responsible for 28 equipments. Their average, life is about kind of a little bit over 8 years. So there are costs associated with it. There are, part labor. And what the challenge was is that they felt like they were having a lot of corrective maintenance versus preventive maintenance. And so they try to actually be more proactive and to predict those corrective maintenance because they're typically a lot more expensive than predicting something in advance. And so what we did is that we relied on the history or the maintenance history that this customer had available. And then we were able, just by looking before going into this whole, machine learning step, we were just trying to draw some, conclusions coming from the data. And if we think about equipment, think about, the car, right, that you drive on a day-to-day basis. When it's a new car, the chances that it's going to break down are very low, right? And we're noticing similar patterns with the equipment. So here, nothing was happening to any of the assets during the first 3 years. During the year 4, right, that's where we kind of start seeing that, there is some sort of maintenance that starts to take place. It actually, starts spiking throughout the life cycle of an asset. And so what we were doing is that we were using some of this history. And in addition to this history, we also were trying to combine and use some of the IoT data that was also available. History helps us predict a lot of aspects, but also having some of this additional feed about the state of equipment as it currently is also very helpful. And so we have, a combination of the different temperatures, humidity, pressure. So those are this type of the information that we fed into the machine learning. And at the end, the output that it provides to us, kind of from the predictive perspective, is now, instead of me having to go through each one of those 28 equipments, and some of the times, users are responsible for hundreds of equipments, now I know that there is actually only 3 equipments or assets that are at risk by taking into consideration all of this histories that we were looking at and some of the IoT readings that we have. And so those are the ones that I, as a user, should focus on. I should go into my system and create a work order and whatnot. And the other piece, and I think we touched a little bit on it, what's also important, Asan talked about the adoption, right? It's important to understand why machine predicted what it predicted. And we also try to provide some additional insights into why the predictions were this way. What we notice, the age of the asset is one of the biggest drivers, right? So the older it is, the more chances that it's going to break. The days since the last maintenance that you have done, same concept. If you take your car to shop, most of the time for the maintenance, they'll look and they will find out certain issues before them happening. And there were a couple other things, that are kind of ranked here. Obviously, this is all the outputs that we show back to the user, but there's a lot of things that are happening behind the scenes, which we rely on the Coleman for. And so for this particular prediction to take place, we actually had to create more than 9 quests per se, and I'm sure we can talk a little bit more details about it, but I'm just gonna quickly
And
just
for the sake of the viewers, take just a second to explain what a quest is, because that's not a normal machine learning term.
Yes, actually, Kevin, I'll take you up on the quest explanation.
Sure, that's our term for our normal data science activity kind of workflow. So you could have a quest that does something small, like make a small change to your data. You could have it be the full model. You could export something back to the data lake, but it's just a little bit of a workflow kind of in this block form that our UI gives us to accomplish one simple task or many tasks to be a little more complicated.
And just from a product owner perspective, I'll just give you why we gave the name of a quest to it, because we are searching on the data for, well, that's what the tool is doing for you and giving you the intelligence, which is getting rendered the way Tanya has shown in the dashboards. So that's the reason why we call it as a quest, because that's what the flow, the data, the process flow out there is doing behind the scenes for you.
So I think I interrupted Tanya there a little bit. Thank you for that explanation.
No, thank you actually for jumping in, Keith.
So
Some of
why
the
did
things
it-
we keep using them all the time that you actually forgot that we need to take a step back and write the
our own
definition.
terms. So why was there 9 quests? Why wasn't it one quest to go on this this journey of a
Exactly.
quest to get to what assets need to predict which assets will need maintenance? Why was it 9?
Yeah, exactly. And so what's very important for us to understand is that as the data comes in, we cannot just feed it into the algorithm just like that. It's important for us to do some cleansing of the data. So some of the quests are responsible for identifying the anomalies, what is the things that actually we don't expect to repeat again. The other question, I'm just showing you one of the examples of the IoT. If you just feed IoT data is this, and you just continue to feed temperature throughout the day, if you continue to feed some of this pressure, vibration throughout the day, this is not going to be a sensible indicator for the machine learning. So what was important to us is actually to find the deviation. The asset is going to fail when the average temperature, temperature from the average is going to jump over a certain norm or drop over a certain norm. And so that's exactly why we have some of the quests that are actually doing some of this additional processing of the data in order to feed it into the algorithm in a sense that it will start using it. And so that's just one of the examples of how we did it. And as you can see, there are some outputs of it that we feed back into our machine learning. The other outputs that we just use for displaying in our BI tool Burst. And so the quests and the combination of those things is just very important. We try to not get customer into this whole sausage making process of what we're trying to do. We really try to focus on your actual business problems and let us use our templates to kind of go behind the scenes and compute the age of the equipment, the moment that you give us just, when it was manufactured, some of these features processing, pre-processing, and then we train the model. And some other quests are really just more of the outputs of the accuracy. And when we talk about accuracy, we just don't want to give you an output of the model. We want to compare it either with your current process, if you had some sort of previous predictions that you used to follow, or if you don't have anything, we want to compare it against some sort of naive method or the benchmark. And so that's why we have a combination of the quests. Each one of them is responsible to answer or to do a step toward the bigger goal.
I think another good reason for multiple quests is, machine learning models, they do go stale after a while. And if you have constant new business data to feed into your model, you might have an automated retraining process. Once a month, this quest gets run, and it's a little different than some of your other quests. So you don't need to run everything all the time, but you could say, okay, once a month, this activity needs to happen.
That makes sense. That makes sense. So back to your first screen you were showing, it looked like a dashboard, right? And
Yes.
it was letting you analyze the output of some of the data coming from the machine learning models. I'd say this is a human consumption, example of human consumption of the output of the machine learning quests. Is that typically what you focus on in one of these implementations, is how the users can then analyze what's coming out? Or are there also machine outputs? Like, are there machines consuming the output and doing things from it as well?
So when we design, and I'm gonna also let others to pick up some of this, but when we design our solutions, we really want to focus on the whole kind of user experience of how you would use this information. So by keeping key personas in mind, so someone would be more interested kind of in managerial aspect to understand what are your costs. So we have some sort of descriptive analytics for them. The others will be more interested to understand, if the organization has a data science organization, they'll be more interested to understand, okay, how accurate is this model? And so we have some of the views to talk about the accuracy and the bias and the distribution and things like that. So it really depends. Some of our customers have a burst BI, and so we'll be happy to reuse those dashboards for you. If you don't have those, that's not a problem. We can always trigger a workflow to send you an email with this list of those assets that are about to fail in this particular example that we are talking about, or we can put it on a homepage screen so that you again get to see some of these insights. But yeah, the main goal for our team is to make sure that we supply you with this information so that you can save time and you can make better, faster decisions. But then, of course, there are a lot of outputs that will go in and will enable other teams to act on this.
So you mentioned workflow there. So that would be, to get back to my question about machine, some kind of automation that would go in and ask for the outputs and then maybe route that data to people and make sure that certain people saw it and they acknowledged that they saw it or took action on it. That would probably be a more of a robotic or automated output from this process.
Yes, and that's a great point, because at the end of the day, the moment that you start adopting some of these outputs that are coming out, and if you feel confident, right, that, every single time when I get these predictions, I see that I do need to schedule a work order, we can actually not have the user go through this process of manually verifying. We could send it directly in one of our cloud suite systems, or we can send it into your ERP system. And so then the work order can be automatically created so that the technician will come and check out the machine on site.
Okay. All right. That makes sense. All right, question coming in from Jeff. He says, thanks for organizing this. It's very insightful. Based from your customer experience, what is a good indicator that customers' existing data, the data collection points, and their process is mature enough to take up an AI ML project? How do you know that you're at the point that you could apply Coleman to your business process? Mature enough is a good word.
Yeah, so let me start, and then I think the rest of my team will also complement and add more points to it. To start with, machine learning is all it's mining on the data, it's learning more on the data. So we need to have good data. When we say good data, at least a minimum of year, depending on the use case, of course, the problem statement that which we want to solve. But a minimum of 1 year data is what we would surely require. And if you look to the top 5, if we categorize the problem statements, you either forecast, you predict, you prescribe to, you want to be having a prescriptive behavior, or you are doing some recommendations, or you are determining some anomalies. These are the most common things that which we try. If you look for words, right, when you look to your problem statements, these are the 4 or 5 categories into which you look to your problem statements in. And for all of these, depending on the scenario, so let's say when you want to do it for forecasting, then usually you need to have at least 3 years of data to learn the trend, right, the time series trend, how the behavior is, and so on. But at the same time, when you want to do some predictive behavior, maybe 12 months data, because your system's performance, anything older is always, you close your books before that and you start. So usually 12-month data would be good. If you are doing something on anomalies, then again, you need to know what is the period for which you are looking at. And usually it is like 6 months to 1 year data. So each of the problem statements or the categories would require certain criteria of data that which is needed, the lineage of data that which would be needed. And but the important part is it should be a continuous data, right? That is something that which is very important. It cannot be that you have a data from 2020 Jan to March, and then all of a sudden everything is silent and you have some data in December. When you don't have continuous data, then again it's very difficult to learn for the system. Or if the problem statement is such that you are not worried about it, then it is something, again, it depends on the problem statement, but in general, you need to have continuous data. You need to have a minimum of 1 year data that which would be needed. And yeah, whether the process is mature or not, that is something only when we look into the data we'll be able to determine. But at least what we believe is that if you have a data like this, then it's a good starting point. And I'll just quote on what Tanya has said. Maybe when we start with a problem statement, we start with X. But then if the data is indicating something else, then we tell you, or a data scientist will tell you that in order to solve your original problem statement X, we need this kind of data. So let's gather that. But for the data that which you have, we can solve another problem statement. We see something in your data that which is indicating some scenarios which will be Y. And we will be able to give you those insights. So data, rich data that which is there is always great things to learn out of it. And that is something which we can always start. So if you have at least a years of data in the data lake, good to go. There will be some, we'll be able to address some scenario or the other for you.
I think also sometimes having labeled data, historical data where you already know the result is very important for training a lot of these models. You need to know, for example, I think one of the classic examples is the, a housing model. If you're trying to predict the sale price of a house, you kind of have to have a lot of data that already has that answer for the model to learn off of. And I think that's an important part of your data maturity.
Yeah, and if
on the top,
I may, I want to add.
Oh, go ahead, Hassan.
Yeah, if I may, I want to add to what Sardar and Kevin mentioned that was great explanation is if we look into what we want to achieve, then there are probably some additional processes that we need to set up in place to make sure that the data they are collecting doesn't have missing values or have consistency in collecting of the data, because we might have collected some of data, but over time, maybe the labeling process changes slightly, maybe some of the sensors didn't collect their data at the time, and there are gaps in the data that make some part of the data unusable. So it's better that we focus on what we want to do, and then based on that, try to set up the processes that we can leverage the existing data and set up the correct processes to collect the data more intelligently for the future.
And I think the key is to not get, intimidated about, oh, I might not have this or that data. I mean, at the end of the day, we are Team Infor are there to help, look into the data that you have and see, like, for example, in some of these assets that I was just showing, right, in some cases, there's no clear markings whether it was, corrective or predictive maintenance, and we were able to create some of those quests that will categorize it. So we'll be there to help and solve some of these problems. And the other thing, beauty of the machine learning is that, yes, you might not have history for all of the products, for example, that you want to forecast, but you have attributes for those products. The moment you have some sort of hierarchy and attributes, we can start learning from it. If, let's say, the color red, right, of something that you want to predict, and we already have some observations of the color red that does have history. So some of the things just be mindful about that. We are there to help. Recently, we have launched this program that's called Augmented Intelligence Subscription. So even if you don't have, the expertise within your own team to do that, we have the expertise containing data scientists, data engineers, and the solution managers who can set or help you get on this ground.
I think that's really important, Tanya, that I hear all the time that I don't have a room full of data scientists, right? I don't have a budget to hire a dozen PhDs. There's no way I can do AI ML in our company. But what I'm hearing is, like from Strada, if I got a year's worth of data or a lot of data points, if I've got the data labeled correctly, maybe I've been even exploring it a little bit in Excel or just other tools, and I can understand the data, and I can contact Infor to bring their data scientists in to help me explore it, I'm set. Right, I can actually begin on one of these projects.
Yeah. So just to add, Keith, one other thing commonly we keep hearing is that because as we know, Coleman AI platform is in the multi-tenant, it's only in the cloud. most of the customers think about, okay, we are in the journey of moving from on-prem to the multi-tenant and our ERP. We don't yet have the full data there. So maybe we are not yet at a stage where we can leverage Coleman. These are the kind of inhibitions or things that which our customers usually come up with. And that's where we say that as long as the data is available, our rest of InfoOS services are there, which will help you to move the data from whichever location, be it from your erstwhile ERPs or your on-prem ERP, Infor ERP itself, or single tenant Infor ERP, to the data lake. And from there, we build the intelligence. And the intelligence, the learning is always useful. Knowledge is always useful at any point of time. And that is what we need to really, we can leverage. So it's a journey that which we can take right from when you decide to embark on moving to the multi-tenant cloud. That is what I would really like to say. Maybe after we answer some other questions, I can come back to some use case where for a customer, the customer came up with an idea of how he wants to use AI first while they are moving from their on-prem to the multi-tenant. That was a very interesting case.
Go ahead and share that use case. Go ahead.
Okay. Yeah. So what this customer is doing is they are moving from their on-prem to multi-tenant, and on-prem they have been using our Infor ERP for the past 10 years. So you can imagine that they are going through the acquisitions, companies are mergers and happening. So there is a lot of data that which is getting into their system. Now, and because of the data, you have lots of, let's say, transaction systems and so on, that which is available. So now what they were looking to is that they want to clean the data. It doesn't matter that all these data may not be needed in the new instance that which they are creating. So they plan to use AI to do the duplicate detection in their master data. Let's say you take the vendor's data, then you try to find the duplicates. And because the business users can't go through those thousands of vendors and find out if there are duplicates. Rather, the machine learning is going to tell them what all look duplicates, and immediately they make a decision, and then they go towards the solution, right? Move it to the multi-tenant system. So even AI is in the journey, starting from their data migration from their on-prem to the multi-tenant. You are able to use AI. It's not like a post scenario of go live. You can start going hand in hand right from the beginning. That was when we were talking about use cases on duplicate detection. The customer came up with this case study, and it was like very interesting.
There wasn't a normal business process like procurement or manufacturing or an HR talent process. It was actually a process of migrating to the cloud that they needed machine learning's help with.
Yep.
Very interesting. Tanya, you look like you're getting ready to share something. Was that in the queue or related to this?
That's for Sarda. She wanted to have some backup to just elaborate a little bit more.
A few slides backwards, two slides backwards, Tanya, towards that diagram. Can you go? Yeah, this one. So this is basically one of the questions that which was there was about what are all the components that which are there holistically. We have been talking a lot about you can render in burst, like Keith had the question about can we do automation with workflows and so on. So I thought this picture will give you a good overview about what all you can do. And here, if you look for applied machine learning, there are two parts. How do you get the data in? And what do you do with the data? And once you learn on the data, where do you provide it? How do you render it? Where all can business users use it? So if we start from the inbound, from the business applications, through ION or through the API gateway, we can move the data into the data lake. Yeah, that's the starting point. Because we need to remember why we always talk about data lake. As you know, in the previous session, we talked about a lot on data fabric and data lake. This data lake is a place where you store all your data coming from multiple data sources. And because machine learning is all about continuous learning, it's not like you learn once and you're done. Every new data will give you new insights. So you have to do like in a scheduled manner, be it weekly, monthly, quarterly, you have to keep learning on it. And that is why machine learning platform reads on the data from the data lake. And once it learns, it makes it available through the API gateway for consumption to business applications again. So you can have what we call it as an embedded intelligence, wherein from the business applications, you will be able to make a call to the intelligence and find out what to do with it. Like you can make a call to say, tell me what is the max discount that which can be given, and so on. You can go through ION and make monitors and alerts and workflows, trigger intimations to the business user to take actions. Or you can render it in burst, which is where the user can take a look at it and make further analysis. Burst is the place where we provide, where we say both the business analytics and the predictive and the prescriptive analytics come together. That's the burst scenario. Yeah, just thought I'll try to put this as a summary on how and where this can be leveraged.
These kind of block diagrams are great. So what you're saying is, generally speaking, whatever the data sources are, we'll use our integration platform, ION, to bring that data up to the cloud. We'll then often store that in our data lake because you have streaming amounts of data over time constantly coming in. You'll need to drop that off somewhere, right? In a central repository, and data lakes are a really great cost-effective way to do that. And then Coleman, our machine learning platform, will consume that data on a regular basis, learn from it, train on it, coming from the data lake. And then Burst, our analytics engine, will be taking the output from that machine learning platform, and maybe from the data lake as well, to give humans the visualization that they need to understand it. I think that's a very, to me, at least, I don't know about everybody watching, but to me, that makes a lot of sense. We got a couple of questions coming in. One was from BStill75. What part of the AI journey is the hardest that most people underestimate the time effort it will take? We kind of went into that in the beginning part of the session about the data cleansing maybe being the hardest part that people maybe underestimate. And then Hassan shared the output of the data, not understanding what the output should be that people really want. That's good. Anybody else want to add to that or recap? Anything we didn't cover?
I think an underestimated time, not just for a specific project, but across many projects, is understanding, these algorithms and their assumptions and when you can use them in the right time. And if you have that knowledge, then it's great. And if you don't, it can seem very, very overwhelming. And one job is not going to teach you everything you need to know. So, sometimes having access to those managed services, you can leverage the knowledge of other people who have already done many projects. And I think that's really useful as well.
Yeah, I think we have templates now. We've done this so many times in so many different industries, right? That we kind of, when we go to customers, we don't just start from scratch with you. We use the best practice that we've already learned for predictive maintenance, or for talent management, or for upsell, cross-sell algorithms to in the sales order process, or whatever we're trying to solve. We already have this library, right? So you're right, Kevin. Leaning on somebody who's done this before saves a lot of time.
Yes, and we typically, the moment that we understand at least the area of the problems that you try to solve, we give you examples of, okay, here's the different use cases that we have solved before. That's one of this coincide with what you're trying to do. If yes, great. If not, let us understand a little bit more of the problem. We already can give you like a list of the data that we think is going to be helpful or beneficial. Then we'll work with you to, put this data in the data lake. We'll, cleanse, go through the data. And then this time about like kind of data and back and forth does take some time. But the moment that we are kind of figured it out and we could see that it, solves the business problem, then this whole piece of us kind of figuring out which is the best algorithm to use is very, very, quick process the moment that we can kind of put it all together. And then the other challenge that kind of comes after this, and that's Hassan touched on, is the whole kind of user adoption. That's why we try to make sure that we give you the insights of why machine predicted what it predicted, so that you could start developing trust. And then over time, we notice that a few of the things, the recommendations that are given out of ML can actually be automated. So your processes are being improved and you're faster so that you can have your employees and yourself focus on more value-add activities instead of kind of doing this repetitive manual process that you had to do before in Excel or in other sources.
Well, you just mentioned, this will take some time for the training, and B-Still75 asked about the time. What are we talking about for time here? I know every project is different, but in your experience, when you go to customers and you have to go through the analysis of their data, the analysis of the business problem to solve, are we talking, days, a few weeks, months, years? What's the
We're
average?
talking really weeks. The way how we've sent the data insights, we could do it in 3 to 5 weeks. The moment that we are done with the data insights, it's really within a month that we could start giving you a working version. I think the thing to keep in mind, we don't want to approach it as a big bang. We want to be agile about it. Let's do a rollout strategy. Let's start small, we crawl, we walk, and then we run. And so to us, it's very important to kind of break this journey down into a matter of weeks so that you could start seeing the value right away, and it doesn't take huge investment from your side or months or years worth of effort. They'll start showing you the value within weeks.
Okay, that's very helpful. That's very helpful.
Keith,
Go ahead,
only to add to that point, what we really need to take is the effort, the contribution, right? There is always a participation from the customer side, from the project side. That is something that which they really need to be looking at, right? It is like during this period of 5 weeks, maybe it's not like every day they have to be together with us, but at least once a week, it's more like meeting together and say, this is what we find, this is our understanding, because we understand data, but we don't understand its business meaning. We are deducing the business meaning from it, and we will ratify, we will validate it with the customer. And that's where that collaboration with the customer contact is something that which we should be doing. Yeah.
That makes sense. That makes sense. That's got to be part of the time as well. Okay, one last question from our viewers, I think. This one's from Naresh. As we get data from various streams in huge numbers from an ERP, how easy is it to organize that data to get a specific result as per any business cases to take effective decisions? We talked about a little bit about that in the beginning about how the inputs come in, how we store them in the data lake, but his point about getting a huge number of streams, maybe from different sources, not just the ERP, but we talked about IoT and other sources. Is it just simple? We just dump it all in the data lake and boy, it's solved, or is there more work to be done there?
It is more about, first thing is dumping it in the data lake is very much important. So that's the key part. Once it is put into the data lake, then we would require to understand for the business problem, because if you just take a data, okay, now mine the data and tell what all problems you can solve, that's like mining an ocean and trying to find, let's say, jewels in it, milk in it, and so on. Like you mine the ocean and try to get whatever it can give you. If you go with that approach, then you might find it will take longer, because when we find something, we come back and we say, this is what we found, is this relevant? It may be or may not be. So while the data is important, it is also important on the other side to have the business case. So you start with a business, you have a business case, you also have the data in the data lake. Then the step comes, that is what is the data exploration and data phase, where you correlate for this business case, what are the data points that which are relevant, right? And that is where, again, the know-how from the customer who knows the business and who understands the ERP that which they are using, and the data science team, both of them are very important. So those initial stages, if you have properly set and the collaboration is established, the rest, as Tanya has said, is going to be easy, because once you get data insights, the rest is all about putting a data algorithms, because there are lots of algorithms available. Even when you go into Coleman platform, you will find a quick reference guide where we give you a flow chart and say, if you want to do predictions, then this is where you go. If you want to do unsupervised, if you don't know what you are looking for, then you go to unsupervised learning. If you want to do forecasting, then go to deep AR. we give you some guidelines as well. And as a platform, we are improvising on it to make it easy for the users. But the core starting point is bringing the business and the data science world, right? The people who understand the data together, and both of them understanding and collaborating. The initial few weeks are the crucial. Once you understand it, then it becomes it's like a cakewalk. I should say it's like a cakewalk.
You make it sound so easy, like a cakewalk. I like that. We use that in our marketing terms. All right. So we got about 5 minutes left. Sarada, maybe I'll throw this last one to you. We don't have time to go through the whole roadmap for this machine platform, but if you could talk about maybe one technology or one enhancement, one new thing that's coming that really excites you, that think will kind of change the way we do these projects in the future, what would it be?
Okay. I would say commoditizing AI is a word that which we hear, and that is something which will really help in getting AI as a common practice, not as something which requires a PhD, but rather it is something that which people can let's say embrace easily. That would be a key thing, which will make Coleman AI, get into each and every one of our customer base, right? Every customer will be able to start building their business, or start solving their business problems using AI. That is something that which I would really aim for. That would be one of the key things which I would look to. And from that perspective, I'll just say that we in our roadmap have a topic called as EasyML, which is mainly to get you jumpstart on, okay, here is the data, like the question that which Naresh asked. Here is the data. Okay, it is like a wizard which walks you through, okay, make a choice whether you want to do classification, forecasting, or predictions. What do you want to do? And it walks you through what to make choices, even with not much of knowledge. It's very simple English questions. It walks you through the process. And at the end of it, it will tell you, this is what you asked for, and this is how it looks like. Now you look to the results, and then you can, because it's the questions which you have answered, now go back and refine your answers for those questions to get better answers, better results. So that is something that which we are looking at, wherein it becomes very, very easy for any business user to start with. It gives them a feel, because the more you do it your own, you get that let's say satisfaction and also a confidence. So that is something that which we are really working towards. And of course, there are other key topics like huge data handling, big data handling, that which is there when you get, I think there was this question, you get data not only from ERP, from IoT, from third-party applications. It could be from social feeds, because that's something which is a big thing that which is there. What is the gap between our current ERP and the decision making which someone has to do? It is about today, the key people look into the feeds that which are there and then apply it to the business that's in the minds of those executives or those experienced people. But that's where machine learning brings in both of them together. You build a learning model and you try to get that science help give the decisions for augmenting. That's a key thing.
I love the commoditization of AI. I love that idea. And the EasyML sounds like the kind of wizard that we really need to make some of these steps in the process easier for people to consume. I think you're right. That would make a huge difference. We only got a couple minutes left, so I want to wrap up. And at the beginning, I promised everybody this little cheat sheet for Coleman that we provide. And I want to leave that along with some suggestions of where to go to get some more education and information on Coleman. Kevin, this is your area of expertise. Do you want to share that cheat sheet on the screen and kind of tell people what's there?
All right, so we've got a quick and easy cheat sheet. Nice 2-pager here. Deals with a lot of definitions, types of algorithms that you can access in our platform, some information about how to access the models via the API gateway, and a template for how to kind of design your quests. As far as other resources, we have a technology YouTube channel that is great. We've got a lot of demos on there. We're even creating some little mini projects that you can build and follow along as you get used to the tools. We've got our Infor Technology blog, a lot of informational content out there, especially when it comes to new functionalities. We've got a user community forum. You can talk about what you're doing. You can talk with other users about what they're doing. Really great interactions can happen there. And of course, our product documentation itself. And we've got links to all of these on our little cheat sheet here. You can access them through
With
that.
simple QR codes, it looks like you can scan and it'll bring you right to it. That's awesome. And displayed on the screen right now is the full URL. If you want to type that in or scan the QR code on the lower corner of the screen, and it'll take you right to where you can download this cheat sheet as a reward for staying with us and this whole hour and listening to our experts. I really want to thank our experts for giving their time. That was wonderful. And for everybody who contributed questions. It was a very valuable hour, I think, for everyone. So thank you for watching. Please like and subscribe to our YouTube channel. It really helps us out. And look for us next month. We're going to schedule another one of these. Let us know what you want to hear. We're thinking about analytics and how that applies to business BI. So let us know what you want to hear there. Thank you, everyone, for listening, and have a great week.
Thank you, everyone.
Thank you.
Thanks a lot.